Good evening. To continue KCET previous year's paper problems. Of integration. First problem. Integral sine 2x divided by sine square x plus 2 cos square x. No, this is sin x, not sin 2x. Sin x over sin square x plus 2 cos square x. How to work this problem? You know sin square x plus cos square x is 1. So this is going to be sin x over 1 plus cos square x. You know how? You can write this as sin square x plus cos square x plus cos square x. The entire skill is here. Write 2 cos square x as cos square x plus cos square x. And this is 1. Now, it's a problem of substitution. Put cos x equals to sin x dx is minus dt. So this is minus dt over 1 plus t square. That is minus tan inverse. What is t? Cos x plus c. That is the answer. Supposing the problem given is sin 2x, because there is some confusion. If this is a problem given, if it is sin x, that's the problem. Sometimes the exam will give sin 2x. In that case, what is the method is same. Sin x over 1 plus cos square x. Sorry, sin 2x over 1 plus cos square x. Here, put 1 plus cos square x equals to. I have told you a number of times, differentiation of sin square x is sin 2x, cos square x is minus sin 2x. So, sin 2x dx is minus dt. So, this is going to be minus of dt by t, that is minus log t plus c, that is equal to minus log of what is t? 1 plus cos square x plus c. So, I work both the problem. If it is sin x, how to work? If it is sin 2x, how to work that? Okay, let's move on to the next problem. Now, before I go to the next problem, I would like to give you some results, which if you can remember, some of the problems can be solved faster. It's not that you are not aware of this result, but I'm just reminding you the series results are going to help you a long way. The first one, f dash of x over f of x dx is log of f of x plus f dash of x or root of f of x dx is root of f of x plus. Just to give an idea, Supposing you are given sin 2x over 1 plus sin square x. So if you call this f of x, this is f dash of x. So directly you can write the answer as log of 1 plus sin square x. The previous problem, it was sin 2x over 1 plus cos square x. In that case, this is minus sin 2x, therefore you can write the answer as minus log of 1 plus cos square x. Normally, some problems are given like this. You have to recognize that. The given problem is f dash of x divided by f of x. Can I write the answer? If f dash of x divided by root of f of x, these two types of problems are given. One more problem, dx over x into root of 2 plus log x. So you can write this as 1 by x dx or root of 2 plus x. So if you take this as t, or if you take this as f of x, this is f dash of x. So what is your answer? Root of 2 plus log x plus. Directly you can write the answer. Okay. So these two formulas will help you a long way in saving time, provided you are able to recognize the given problem. Okay. Let's continue. If you are given sin square x over 1 plus cos x is given. See, it is not of the form f dash because cos x will give only sin x, not sin square x. So you have to use the trigonometry formula. This is 1 minus cos x into 1 plus cos x divided by 1 plus cos x. In fact, instead of writing this directly, you could have written 1 minus cos x because you can just orally work it out. Sin square x 1 minus cos square x, 1 minus cos square x, 1 minus cos x into 1 plus cos x, that cancels. So the answer is x minus sin x plus. The next problem given in CET. E to the power of x into x square tan inverse x plus tan inverse x plus 1 dx. So, remember, I had told you whenever e to the power of x is there, especially in CET, it must be of the form like this. It's e to the power of x. So we have to work it out. You can write this e to the power of x into x square plus 1 into tan inverse x plus 1. You can write this as e to the power of x into tan inverse x plus 1 over x, 1 plus x square. How? Dividing by 1 plus x square. So if you divide by 1 plus x square, you will get 1 plus x square outside. So the problem they have given x. You can't just divide. They have given the problem. X square plus 1 is given here. So you have got x square plus 1. Because when you divide, you have got to multiply also. The problem itself has got x square plus 1. Now separate it. X square plus 1 cancels, you get this. This is f of x, f dash of x, and the answer is e to the power of x in the answer. Please make the correction. The problem itself x square plus 1 is there. If that is not there, we can't work it out because divide, then I should multiply. It will come out, and you can't take it outside integration sign because it's not a constant. Only k into f of x, k can be taken outside where k is a constant. So I think it's clear. After this, you can separate into two terms. You get this f of x and f dash of x. The problems are very simple provided you are able to recognize the format. The next problem given is a very simple one. E to the power of 6 log x minus e to the power of 5 log x divided by e to the power of 4 log x minus e to the power of 3 log x. See, two things are important. One is first writing n log x as log of x to the power of n. The second thing is e to the power of log of f of x is equal to f of x. When you apply both of them, you get x to the power of 6 minus x to the power of 5 because the 6 will come here. X to the power of 4 minus x to the power of 3. The maximum common factor can take out is x to the power of 5. Take it out, you get x minus 1. The maximum you can take is x cube. You get x minus 1. These two will cancel. So you get x squared dx. X cube. Such a simple problem, provided you remember these two results. Let's go further. Dx over 1 plus 3 sine square x, 3 sine square x plus 8 cos square x. So these are all very interesting problems. And by working this at home or practicing this, you can recognize the problem of similar type in the examination. So working at home is very, very important. So what we do is from this 8, I'll take 3 and give it to the sine square x. So 1 plus 3 sine square x plus cos square x plus 5 cos square x. So 8 is written as 3 plus 5. This becomes 3. The problem becomes dx over 4 plus cos square x. So an interesting problem. What we do is we multiply by secant square x, both numerator and denominator. See, you got secant square x, and which function on differentiation gives secant square x? Tan x. But you have got secant square x. We need tan x. Convert it. Secant square x over 4 plus 5 plus 4 tan square x. Do you follow why it is 5 plus? Because secant square x 1 plus tan square x, 4 into 1 plus tan square x plus 1 5. Now put tan x equals to secant square x dx is dt. So you can do one thing, put 2 tan x equals t, you get half dt. So dt over root 5 whole square plus t square. That is 1 by a. So it becomes 1 by 2 root 5 because You got half outside. Tan inverse T. T is 2 tan x by root 5. So if you can understand that, it's a very, very simple problem. So let's move on to the next problem. dx over 1 plus e to the power of x. Very, very simple problem, provided you have worked. You have to write this as e to the power of minus x over e to the power of minus x plus 1 dx. It is log minus log e to the power of minus x plus 1 because we have dash of x over f of x. We are getting a minus sign, therefore you can take minus log. But normally they don't give an answer like this. So what you should do is you have to again reconvert this 1 over e to the power of x plus 1 minus log of 1 plus e to the power of x by e to the power of x plus 1. So we have got this answer, but answer will be this format. So because you express in terms of e to the minus x, they had not given it. So come back to the expected form. This is the answer. So this is where some difficulties lies. Where? How to arrive at the answer. These are the points where in working the problems in the class at home, concentrate on this. The answer given may not be in the form of the answer that you have got, but you should know how to convert it. So you would have got this answer, you are searching for this, it is not there. You might you are forced to take none of this. Normally, none of this is not given, and it's always one of these. 90% the answer will be one of these. Definitely, it is one of these. So whenever you have got doubt, you have got to express the answer in the format. They would have given answer in this format, and you have got the answer in this format. So, yeah, but you have taken e to the power of x, 1 over e to the power of x. Again, reconvert it. Then you get the answer. So these are the areas where you have got to be little more cautious. This problems looks very big. Would have worked in the class, but I'm just working it out because they have asked this in the CET examination. Very simple one. Tan inverse of x to the power of 4 over 1 plus x to the power of 3. Very simple problem. Put tan inverse x to the power of 4 equals 1 plus 1 by x square x to the power of 8 into 4x cube differentiation of x to the power of 4 dx is dt. So you don't have 4, so shift this 4 to this side, you get 1 by 4 here. So what happens to the problem? 1 by 4, you get sin dt. It's a very, very simple problem. Because x cube over 1 plus x to the power of 8, t sin dt. Tan inverse x is equal to t. So we get t sin dt. How to work t sin dt? Sorry, not t, just sin t, because this is t. Sin t. Sin t is minus cos t minus 1 by 4 cos. What is t? Tan inverse x to the power. It looks very big, but nothing. If you are taking this, so this becomes sin t. The entire thing becomes 1 by 4. So answer is this. Let's go to the next problem. Integral x square over root of x to the power of 6 plus a to the power of 6. You get a clue here. You have got x square. Which function on differentiation give x square? It is x cube. So you can write this as x cube whole square. So let us put x cube equals t. The clue is here in the problem itself. So x square dx is 1 by 3 dt. So this is 1 by 3 dt over root of t square plus a square. What is the answer for this? You have to recall the formula. Dx over root of x square plus a square is equal to log of x plus root of x square plus x. Use that 1 by 3 log of x. What is x is? So it is log of t plus root of t square plus a square plus t. And substitute for t. What is t? T is x cube plus x to the power of 6 plus a to the power of 6. So these are all the problems which are from indefinite. Now directly let us move on to the definite integral problems given in the CET examination. So before I go for that, I'd like you to remember some of the standard formulas which will help you in a long way. First formula, 0 to pi by 2 sin to the power of nx or cos to the power of nx plus sin to the power of nx dx is pi by 2. Where n can be greater than 2, because if n is equal to 2, it becomes even then you will get pi by 4 only. But the thing is, you need not work it out. Of course, if it is n is less than 2, the answer is going to be different. So n greater than 2. Similarly, a problem can be given in the same form: 0 to pi by 2 a sin x plus b cos x over a sin x plus cos x. Remember, the answer is a plus b into pi by 2. So they will give 3 sin x or 2 cos, whatever it is, you can just. So what is the answer for this now? 0 to pi by 2, 3 sin x plus 5 cos x over sin x plus cos x. So if you remember this answer, a plus b is 8. So 8 into pi by 4, the answer is 2 pi. Immediately we can take the answer. Some more formulas we need to remember. These are all standard formulas. 0 to pi by 2 dx over a square cos square x plus b square sin square x. Remember, the answer is pi over 2a. Just supposing we are given a square as 16 and b square as 25. So a is 4 and b is, can substitute and get the solution. And 0 to pi x sin x or 1 plus cos square x is equal to pi square by 4. Pi by 6 to pi by 3 tan cube x or tan cube x plus cot cube x. Of course, okay, I could have taken n also. This is equal to half of pi by 3 minus pi by 6 into pi by 4. That's equal to pi by 2. The another problem, a to b root of something like 10 minus x or a minus x, 10 minus x over root x plus root of 10 minus x dx is equal to b minus a into pi by 2. No, it's just b minus a. No, pi by 4 is not required, b minus a. Half of b minus a. Remember, it's half of b minus a. For the problem, we shall work it out. 3 to 6 root x over root of 9 minus x plus root x. The answer is half of b minus a. b is 6, a is 3. So 3 by 2 is the answer. So if you remember these formulas, working some of the problems is going to be very, very easy. There's some more I have listed. Let me just give you. 0 to pi by 2, pi by 4. Integral 0 to pi by 4. Log of 1 plus tan x dx is equal to pi by 8 log 2. If you remember, these are all standard problems. 0 to pi by 2 log tan x dx is equal to 0 to pi by 2 log cot x dx is equal to 0. Zero to pi by 2 cos x minus sin x over 1 plus sin x cos x, or this is equal to 0 to pi by 2 sin x minus cos x over 1 plus sin x into cos x dx is equal to 0. So if you can remember this, lot of time is saved in the examination. 0 to pi by 2 2 to the power of sin x or 2 to the power of sin x plus 2 to the power of cos x dx is pi by 2. Integral 0 to pi by 2 log sin is a very difficult problem. Takes so much time to work in the regular class. Log cos x dx is equal to minus pi by 2 log 2. So if you can remember this, you can save a lot of time. So let us let's work some problems based on these types of results. Let us begin with the first problem. First problem, 0 to pi by 2 . 0 to pi by 2 sine to the power of 100x over sine to the power of 100x plus cos to the power of 100x is given directly written as pi by 4. Can save a lot of time. 0 to pi by 4 log of sin x plus cos x by sin x plus cos x by cos x. See the examiner's intelligence. It's a very simple one. You can write this as 0 to pi by 4 log of tan x plus 1. That is equal to pi by 8 log 2. So I'd ask you to remember log of 1 plus tan x is pi by 8 log 2 here. I've just twisted it. These are all the tricks you see in the exam. If you can recognize that, the problems are going to be very, very simple. So better you remember the problem this format. A to B instead of given for 10 minus x. You can take it for any problem in general. F of A plus B minus x dx. This is half of B minus A. I just use this formula for that problem, but you remember this. F of x plus f of x plus f of A plus B minus x. So one of the years they are given this problem 0 to 4042. The moment you see the problem, you feel it is very difficult, a very big problem, but there is nothing in this problem. Root x over root x plus root of 4042 minus x. This half of b minus a is 0. So 2021 is the answer. Zero to pi by 2 dx of 1 plus tan cube x. So without working the problem, you can write this pi by 4. Why? If you write tan sine by cos, you will get cos cube x over cos cube x plus sine cube x. That's the standard formula and equal to pi. The next problem. So please make this correction. I've given these values 8 and 10. Now you take it as 8 plus b minus x. So that you can recognize that format. F of x plus f of a plus b minus x. 0 to 1 dx over e to the power of x plus e to the power of minus x. So you can write this as e to the power of x over e to the power of x whole square plus 1 dx. I think you can recognize this. I am writing this 1 over e to the power of x. Then take LCM. So put e to the power of x is equal to t. E to the power of x dx is dt. So this is equal to dt over t square plus 1. And this tan inverse t. What is t? E to the power of x plus. Another problem on the CET. Integral 0 to pi by 2. Integral 0 to pi by 2. Cos x sin x or 1 plus sin x. See, these problems, if you have not seen If you are not worked it out earlier, will give you a trouble. Because if you put sin x as t, you get cos x, another sin x left over. So what the method is, put 1 plus sin x equals t. So cos x dx is dt. Let us change the limit also. When x is equal to 0, t is equal to 1 plus 0, 1. When x is equal to pi by 2, 1 plus 1, because sin pi by 2 is 2. The problem becomes 1 to 2. This cos x is dt. Sin x is t minus 1 by dt. This is what you should recognize. How to integrate this? 1 to 2, separate it. 1 minus 1 by t dt. That is t from 1 to 2 minus log t from 1 to 2. 2 minus 1 is 1. Log 2, because log 1 is 0. So 1 minus log 2 is the answer. Another very interesting problem, because these problems you need to work as fast as possible. How many steps that you write depends on you. You can't write all the steps, and you can't work without writing minimum number of steps. Some of the steps you have got to do it mentally. So I've given you this instruction at the beginning of before we started the CET session. Try to write as little as possible. So let's go to the next problem. 0 to pi by 2. Root sin theta into cos cube theta. So we cannot, both have got power. If I take sin theta as t, I'll get cos theta, but cos cube is there. So what I should do is I should do some trigonometric substitution. What is that? I can write this as sin theta into 1 minus sin square theta into cos theta d. The cos cube is written as cos square into cos 1 cos square is 1 minus sin. Now you can put sin theta equals t. Cos theta d theta is dt. Change the limit. When x is equal to 0, t is equal to 0. All this there is no need of working, but I am working here. Right? CET you can directly write this. So t is equal to sin 90. And this sin t x is equal to pi by 2, t is equal to 1. So it becomes 0 to 1 root t to 1 minus t square dt. So simplify this. Root t minus t to the power of 5 by 2, 2.5. So this is half plus 1 is 3 by 2. That is 2 by 2. 3 to the power of 1, 0 to 1. 5 by 2, 7 by. So 2 by 7. 3 to the power of 5 by 2. All this you can avoid writing. You can remember this nothing but 2 by 3 minus 2 by 7. Or 2 into 1 by 3 minus 1 by 7. It is 2 into 21 is the LCM. 7 minus 3 is 4. Therefore, the answer is 8 by 20. How fast you work it out, it depends on you. The next problem. Integral 0 to 1 root of 1 plus x over 1 minus. Now here, this is a standard problem, and we would have worked this in the class, and there is no other method. You have got to write some of these steps at least. So let us remove this numerator root. How? Multiplying by 1 plus x, both numerator denominator, get 0 to 1, 1 plus x over root of 1 minus x square dx. What is the next step? Separate it. dx over root of 1 minus x square, this sin inverse x, plus x over root of 1 minus x square. Play some game, write this as half and 2. So this is sin inverse x, put it 0 to 1. And this is f of x over f dash of x over root of f of x. So this adjustment you should learn. I need 2x, so this is equal to half root 1 minus x. But the problem is not over because it's a problem of definite integral. So you have to substitute and simplify. So this is sin inverse 1 minus sin inverse 0 plus half of 1 minus 1 is 0 plus half only. So this is equal to 1 plus half, that is equal to 3 by 2. Oh, I'm sorry, not 3 by 2. Because sin inverse 1 is 5 by 2. 5 by 2 plus 1 is that. So we have discussed some problems of integration which have been asked in the CET examination. So the next part that I will be discussing in the next class, differential equation. While solving the previous year's paper, one session I have taken on differential equation. Because the most important thing is order and degree. Then solution by variable, separable, homogeneous, linear. There are 3 solutions, 3 methods of finding solutions. And I have discussed that in my one session while discussing the differential equation. You can just refer to that. So tomorrow, when I start differential equation, I am not going to brief anything because I think I have spent more time there when I was discussing the CET paper, rather the question papers last month. And I think 2 sessions have taken total. One of the first session I have explained what is differential equation, what is order, what is degree. So tomorrow when I start the classes, I will not be discussing the problems of order and degree because they are very simple. I will not waste time. We will only solve the equation. What are the methods we have? One is variable, separable, homogeneous, and linear. So those things, I would rather expect you to go through those things, and when you attend the class tomorrow, it's going to help you. So tomorrow we'll discuss about the questions which are appeared in the previous examination. Though they are simple, let us go through that. And today we shall wind up the class. An instruction that we shall meet tomorrow for differential equations. Okay, thank you.